My name is Roger Ye, and I'm here with John Sheehan to talk to you about leveraging the combination of Creo Elements Pro and Mathcad Prime to help us with engineering tasks. We will use an example from the aerospace and defense industry. For this example, let's say I'm a systems engineer at a defense contractor. We just won a major contract for a missile program. My team is designing the missile head. The electrical team is working on the guidance system and controllers. I'm working most closely with the mechanical team, which is composed of the structural team and the aerodynamics team. The structural team is making sure that the missile will hold out during its launch and trajectory. The aerodynamics team is putting fins and air brakes on the missile for stability and speed control. As the systems engineer, I need to make sure that the requirements set forth in the A-spec, or A-level specifications, are met. There's a requirement that states that the missile shall be able to provide X amount of drag at various altitudes in order to control its speed. The mechanical team is employing air brakes or drag brakes to do this. In the following example, we will see how Mathcad can take this requirement and transform it into an area measurement for the air brakes. Specifically, the holes on the brakes need to be sized to certain diameters to provide the required drag. John will now walk us through the process of using Mathcad Prime and Creo Elements Pro in this missile air brake design.
As you can see, we have designed in Creo Pro the prototype missile. We wish to optimize the design of the air brakes on this missile to meet specific requirements. For this, we will use Mathcad Prime. In the Mathcad Prime worksheet, we have our parameters which we can enter or can be driven from the Pro model. So here we have altitude and we have V for the missile velocity. You'll see in the presentation that these are actually going to be driven from the Pro model. As we continue, you'll see that we have units on our terms in feet, in knots, and Kelvin. As we continue to scroll through this, you'll see some constants being used. A lot of these constants can easily be found in the Mathcad user interface. And then finally, our calculations are taking advantage of Mathcad's ability to use natural math notation. So we simply type in the calculations the way that we see it in our reference materials. Here we're computing rho, which will be used as the barometric pressure of the Earth's atmosphere. We're going to use all these inputs now and do our drag force calculations. And as you can see here, we document very nicely what the parameters and what the inputs are and what we're computing. We're actually computing, we're looking to find the reference area. And what we're going to do is show this across a number of areas now. We create F sub D with our drag force calculation. And as we go, as we iterate across the lower to upper boundary of our areas in square feet, we can see what the resulting drag force will be. Finally, we're going to just do our area calculation, solving for the total area, and then we'll see what the square footage is for a single brake and see if we're meeting our requirement for the resultant force. So Mathcad is a document that allows us to use natural math notation and to capture the knowledge around the parameters and the calculations. Back in Pro, what we do is during the regen process, we're going to take the flight altitude, the missile velocity, and the maximum allowable drag force, and we're going to send those over to Mathcad Prime through the Mathcad analysis feature. And what we'll do is we'll simply come in here and modify our requirements. Instead of 2,800 newtons, we'll change our force maximum to 2,900 newtons. During the regen process, it will actually go off and open that Mathcad worksheet, send these three parameters over, and it will bring back the computed area with the new results. We can then share that result because it is a global parameter within Pro. You see our update here. It is a global parameter within Pro. We can actually use that in other tools within Pro. So we brought back that area, the square foot of 2.431, after we've changed our constraints or our requirements, have changed the maximum allowable drag force to 2,900 newtons. Recalculated that worksheet, brought the result back, and now I can actually tie it into other tools within Pro. For example, I can go to a feasibility and optimization study where I've actually selected the interior surface face of this hole. And what we're going to do now is just highlight this, and let's just do a study. Run this from, we'll iterate this from 1 to 4, and I'm going to compute that. So we're going from the design tool in Pro, creating the model, sending that over to Mathcad to have analysis done to see if we're meeting our requirements, bringing that value back into Pro, and from there now we can actually do optimization and feasibility studies within Creo Pro.
Thank you, John, for that demo. Let's summarize by seeing how it fits in with the PTC process landscape. The process landscape shows product development and various perspectives relevant to the development cycle. Product development is a set of highly cross-functional and distributed processes that span the life of the product from planning through support. We will focus on the engineering processes. The missile air brake demo we just walked through shows off some of these business processes. First, system design. Creo and Mathcad are clearly very effective products for various engineering departments across an organization. As the systems engineer on this project, the value of integrating the two allows me to verify that requirements are met in an automated and efficient manner. In detail design, we can take advantage of PTC's suite of multidisciplinary products to design and manage electrical and mechanical data. In our example, we were only interested in the mechanical portion. PTC offers tools to help you verify other requirements like, for example, the electrical components in the missile controller and guidance systems. Mathcad can be used to analyze components in various domains and even be extended to standardized calculations throughout the organization. Under V&V, or verification and validation, we have already spoken about using Mathcad to verify requirements. What we didn't talk about was using Creo and Mathcad in conjunction with our PLM solution to not only manage data but also trace requirements. Finally, under variant design and generation, Creo provides a platform that allows you to design and manage modular products. Mathcad can also be used to analyze modular components. In the case of the air brakes, if we needed to apply the same drag analyses to new or modified designs, we can easily change the parameters in the Mathcad worksheet to make sure that they satisfy the new requirements. We hope you now see the value of integrating the capabilities of Creo and Mathcad, and how that works into your organization's engineering processes, whether it be dimensioning the air brakes on a missile, sizing a shaft for the transmission in your car, designing a cell phone case, or an I-beam in a building. PTC desktop tools can help you in your day-to-day work.